Hi guys, thanks for coming for this talk. I'm Robin Randhava. I work for ARM. There's an error in all of the planning material that you guys have been seeing because it says I'm the presenter. I'm not the presenter. I just arranged this. The presentation is being done by David Jordan from System 76. But just as a way of introduction, it's like these guys design hardware that's for Linux, right? I heard about them from like a friend of mine had a really snazzy looking laptop, funky vents and what have you, and she was running Linux on it, and I just automatically assumed that nothing would have worked on it because it wasn't a Dell or a ThinkPad. So I thought like ACPI, brightness, suspend, resume, and she must be suffering all of that. But she was like, no, it works very well. And then she showed me this preference dialog for secure firmware updates and all of that, and I was like, what? How does this work for you? And she said, no, it's System 76, and I just bought the laptop from them. Now, at the Linaro Connects, the ARM on ARM story is now becoming a recurring theme. And I thought it would be a good time in this Connect to actually reach out to System 76 because they do commercial grade laptops and desktops, and they've even done an ARM server. So the idea was perhaps they can tell us about their experiences, and we can have a discussion on what needs to be done to get laptops from System 76 which have ARM processors in it. Yes, but we'd like to have laptops. Right, so you have a, is that working? I don't think that was working. Yeah, take this.
Okay, so yeah, I'm David Jordan. I work at System 76. And I wanted to talk exactly about where ARM is today as far as what an OEM needs to deliver an ARM desktop, an ARM laptop, and be able to support that properly. So right now, ARM has pretty much conquered mobile. If you've got a phone, a tablet, IoT device, it's probably ARM. ARM is on servers. This is actually System 76's ARM server. We deliver it with Ubuntu and support it, deliver it, make sure it works. But on the desktop, there's Chromebooks. There are quite a few desktop, laptop-ish devices, at least in the sub $500 consumption area. Microsoft has tried getting into the ARM space and has had kind of a rocky start with that. But the ARM Linux desktop, I've seen like one. It was sitting out there in kind of the main lobby area there. And there were a few things that I'd like to talk about that were very illuminating about that workstation design and why it's probably designed the way it is. But first, I'm going to talk about what System 76 does as far as delivering a really first-rate supported Linux experience. So we sell laptops, desktop servers, and for the first decade of our existence, we specifically sold machines with Ubuntu. It wasn't that we didn't have users who were using Fedora, Arch, all of the other distributions, but when it comes to being able to ship something and know that everything works, you kind of have to limit your target for what you test against, what you guarantee works. And since then, we have our own Ubuntu-based operating system called Pop! OS that's specifically designed to allow us to customize and deliver additional enhancements and user experience beyond the kind of control that we had with Ubuntu. Desktop Linux is our bread and butter. We live and die by how well Linux works on our machines, how well we support it, what kind of features and benefits we can give to creators, makers, builders, scientists, engineers, developers. And we need to be able to ship modern versions of Linux. We can't be waiting 3 months, 6 months, 2 years for a particular version to be supported. We need to have support for every single hardware that we've sold in its life cycle on the day the new release comes out. and we do deliver both LTS release, the latest one, as well as every 6-month release. And that's important to be able to support the latest hardware and to keep kind of everybody in the same modern, up-to-date systems. So with POP, we started small with theming, particular behavior tweaks that we thought improved the experience. And we, unlike a lot of distributions, offer both kind of a generic Intel AMD ISO as well as one with the NVIDIA drivers pre-installed, because we were finding lots of users had that pain point of, we're trying to install the operating system, they have the latest graphics card, and Nouveau does not work well on the latest hardware the moment it comes out. It takes a little while for that support to be reverse engineered in. 1804, we added out-of-the-box disk encryption, so you get your machine, you can set up full disk encryption yourself, just easily. It's designed to be used that way. We've added support for mixing high and low DPI monitors, because we found you have your high DPI laptop and a low DPI external monitor. You want that to actually match scale and not look ugly out of the box. And we started working on power profiles, GPU switching, so that you can get good battery life and performance and control what you want yourself, regardless of what applications are trying to eat up your power and so forth. So that's what we've been doing the last year, and now we're actually becoming a hardware manufacturer rather than just relying on upstream manufacturers in China. We're actually bringing computer manufacturing to the United States, to our headquarters in Denver. We'll be manufacturing first desktop chassis, and eventually the plan is to start manufacturing custom designed laptops in-house. It'll all be open hardware, and so some components will take a little longer to open up, but slowly, piece by piece, we want to open up the desktop and the laptop. So our customers, many developers, many scientists, many engineers, people who use their computers as tools. It's not I want to edit a Google Doc on my Chromebook. It's I want to develop machine learning, graphics, automotive self-driving machines. Performance is utterly critical. As much CPU, as much graphics, as much RAM as possible. It's a tool. It's designed to last for years, and it needs to be powerful. But there's also a strong desire for more battery life than we can currently deliver. I think that's a place where, especially on the smaller machines, and possibly even on the bigger machines, where ARM could really help, where Intel has struggled to achieve both greater performance and greater battery life. ARM could potentially be the way forward. So as I was thinking about this presentation, thinking about why all our smartphones are ARM processors, but our development tools, generally speaking, have not. I started to realize that there were different life cycles, different use cases, and very different replacement patterns from mobile devices to people's development devices. On mobile, how many people have one smartphone? Just one as a main device. Okay. How many people have two or more? Okay. So some people have quite a few, but a lot of people just have one, and they replace it when it no longer will work as their device. in this model, it does make a fair amount of business sense to encourage users to go to the new device by making operating system updates contingent upon getting a new phone. That also means that it becomes kind of irresponsible to keep a phone past that lifetime because you're adding one more unpatched device onto the internet. With desktops, how many people have just one laptop, desktop, workstation? Okay, I noticed 2 hands. How many people have more than one? Okay, how many people keep around a machine far after they've replaced it as their latest one? Okay, that's pretty common. That's very typical of our users. So what that means is that for us, there's a strong incentive to ensure that computers have good support for far longer than the time between they buy one of our computers and the time that they buy the next one. If their machine is still working well, if it's still getting OS updates, and it runs the latest and greatest, our customers are still going to buy another machine from us. In fact, they're more likely to buy from us if their machine is continuing to work well, and they're replacing it because they want 2 more processing cores or the latest graphics card, or ooh, another 32 gigs of RAM. I'll put that in now. So the value proposition of our machines is to keep them supported and working well continuously with every version of the operating system for as long as possible. That is one of our biggest value propositions, is that it's going to work well, and we're going to guarantee it keeps working well for a long time, rather than, okay, you need this specific version, and the next version of the OS, buy a new piece of hardware from us. That hasn't necessarily always been true for ARM SoCs when it comes to outside of the server space on graphical systems. The GPU driver situation has been pretty bad. That's even bit a number of Intel processors that we've had to choose not to use because of the particular graphics chips that were being used. On x86, generally pretty painless. Intel does a pretty great job of having up-to-date driver support, having it continue to work, often having that support in there before the hardware is actually available on the market. And NVIDIA, it's not open source, but they have done a pretty excellent job of supporting hardware for a long time. It tends to just work except for a few little bugs here and there. ARM SoCs, anybody tried to update kernels with Power VR stuff? Yeah, so that's kind of one of the things that makes it difficult for a vendor like us to commit to a given ARM SoC, is that we need to have suspend working right, we need to have accelerated graphics working right, we need networking and all of these things to just work and continuously work from the time that the hardware is released all the way until the end of life that the user chooses, not the end of life that, it's 18 months down the line, buy a new $2,000 laptop. So what System 76 has traditionally done in the pre-manufacturing era is we've selected the components that we know work. If a vendor had a reputation for dropping hardware support after a release or two, or unreliability across kernel versions, we simply didn't ship with their hardware. For us, it's important that a vendor is consistent about this. that if we pick a particular product to ship, we know it's going to keep working well, and that a year, 2 years, 3 years down the line, we won't suddenly get a bunch of customers calling us about, oh, I can't use the latest version of Ubuntu. What do I do? And if our answer isn't, oh, it just works, or here, install this one package, you know, we can't offer that hardware. So the way forward, ideally what we'd like to see is for vendors to provide first-party open source drivers that they continue to keep updated from, you know, kernel 4.19 to 4.20 to 4.21. And if you do need to ship proprietary drivers for various internal or patent reasons or whatnot, make them freely redistributable. One of the things we do with Pop! OS is we package updated versions of the NVIDIA driver, of the CUDA libraries, of TensorFlow. And if they're not redistributable, if you can't put them in a Linux distribution, that makes it basically nearly impossible for us to actually support your hardware, because users then have to go to your website and you know, use a process that we can't guarantee is consistent. And please maintain your drivers. You know, that life cycle, that, you know, 5 years, 10 years, that's important to just have at least basic driver support so that operating systems continue to work as they advance. So try and track as much in upstream kernel development as possible. Test in distributions. Sometimes there are various versions of things that end up conflicting with each other, small little bugs that get introduced. You know, during the development cycle. So right now, the 1810 development cycle is going on. In a month or so, we're going to have the 19.04 development cycle beginning. Test your hardware against it during that time. And if it's your driver, you know, fix the regressions, work with the distribution at upstream to get those patches in, and report any bugs for adjacent code that might be breaking things. If you are working ahead of the release, that significantly improves things rather than trying to get backports into the release after the fact, having ISOs that don't work, etc. Yeah, let's make Linux just work on ARM laptops and desktops together. Are there any questions?
What were our experiences with the ARM server?
Yes, the ARM server. So we've had some successes with that, some rockiness. We had to adapt our imaging system to build images for ARM. That was a little bit challenging to get networking working in the virtual machine and all of that initially. We did find that 1604 worked pretty well. That was what our upstream vendor had been, Cavium. The current ARM server is a ThunderX. We'll probably be looking at ThunderX 2 hardware at some point. The Cavium had tested 1604, and that worked pretty well. But when it came time to ship 1804, we found that there were some serious bugs that just hadn't been tested with dual processor machines. It seemed when you allowed any more than 48 threads on 1804, there was a bug that had gone unnoticed that would cause crashes. So that's why maintaining your support across releases matters significantly.
My question is about the software upgrade. Do you have experience custom calling to say, okay, they cannot launch certain software?
Testing software with ARM. So Generally speaking, a lot of distributions maintain pretty good packages for a pretty wide range of software on ARM. It's generally not been too bad on software as long as it isn't purely x86 software once you have the operating system support there. If you're lacking accelerated graphics, if your networking stack is broken, if SMP has problems, then the applications have problems. But once you have that foundation there, it's generally pretty good.
Do you have any continuous integration to ensure that new kernel releases don't break your shipping hardware?
Some of the stuff is somewhat possible to do continuous integration on. Some things you actually kind of need somebody actually verifying that, for instance, your hotkeys keep working, and that some physical things are happening in the right way. As we do more manufacturing, we're probably going to be building some test rigs or whatnot to automate as much of that process as we can. Yeah.
One more question about upgrade. Right? Have you implemented this capsule upgrade from the
For firmware updates? So we're not using the capsule method. We do have our own firmware update tooling that we ship with our machines. All of the code for that is open source. Various updaters are welcome to use that as a reference for pulling in our updates from our servers. Actually, unlike the capsule method, you could talk to Jeremy about that. We've actually written open source tooling to handle the installation of the firmware update.
So I'm still puzzled with the requirements that you listed for what you expect from a chip. And the ARM SoCs that are on the market today and coming out in the next 1 or 2 years, I still see an empty set. So what are you actually looking at? Are you looking at repurposing ARM chips that were not meant to be used in mobile or laptop, and then just trying to see if you can fit them in the power envelope? Or are you looking at chips that were meant for things like tablets and see if you can get them fast enough and get the driver situation sorted?
So I think we're not necessarily looking at this SoC or that SoC right now, but we are evaluating which SoCs out there on the market meet the requirements for the software and providing so that we can provide hardware support, not necessarily that we're looking for a particular power envelope at this point.
Okay, so you're looking at high performance ones, then trying to see if you can get it working.
Yeah. I mean, this machine is a System 76 serval. It's not our biggest computer. It's fairly popular, and it actually has, I kid you not, a socketed desktop processor and a desktop-grade graphics card. Some of our customers want something, thin and light and portable. We do sell a 13-inch Galago. Some of our customers want socketed desktop processors and more than one graphics card. There's kind of a wide range, so ARM isn't necessarily only interesting because we want to make it thinner and lighter than a 13-inch Galago, although that's one application. It could be that could be people like you who want an ARM development workstation that portability might be sacrificed in terms of absolute performance and being able to compile directly on ARM rather than having to emulate that. That was one of our big challenges with delivering ARM on servers, was because our image mastering infrastructure was all on x86, which means that process of making the images using emulation was slow, whereas that might have been much faster with, you know, an ARM workstation sitting around.
So that would be more like the field or the Escape class chip than the Snapdragon or chips class.
More than likely, yes.
And then would you put, like, can you connect a mobile graphics card to that? Are there any that
I don't know for sure, and that landscape has kind of been changing over time. One thing I noticed with that workstation out there was that they weren't using an ARM SoC for the graphics. They were using they were using an NVIDIA GPU. So you know, that might actually be one possible way forward to deal with the graphics driver situation, is to rely upon the NVIDIA driver support. There's probably several paths forward. Part of this is to kind of, you know, show our interest and intent in bringing about ARM hardware, as well as saying what we need as an OEM, what's important to us, so that when all of you guys are working on support, you can kind of think about, okay, what does an OEM need, and how do we make this kind of easy to dovetail both ARM, Linux, and OEMs together.
Have you tried talking to ARM yet? Because one of the GPU situation problems is a lack of pressure from outside vendors saying, we need this working. So without people asking to have it fixed, it doesn't get fixed. And I don't know if you've actually tried having that conversation yet.
So it's still somewhat early days on this. You know, if we start to get somewhere with this, and especially as we do more of our own manufacturing and we grow, you know, I could very much see us having conversations with ARM, like, okay, well, you know, we like your GPU design, but, you know, we need the driver support situation rectified, you know, whatnot. So the short answer is no. This is still pretty early, but you know, I could see conversations happening in the future.
Yes, you absolutely need to do that, but that would be more for the slim and light market, whereas the performance computing. If you have any ARM chip that actually does performance, it will not have any GPU inside of it.
But have PCI Express.
It will have lots of PCI Express.
Yes. Who would want an RTX 2080 in your ARM workstation? New NVIDIA GPUs.
I don't want that. I want the 2080 Ti.
You want the 2080 Ti? Okay.
I want the 730. Because that's the only one that works with the open source drive. And you're not going to get an NVIDIA driver from NVIDIA for ARM.
Anyway, I believe they had the 710 in there. Yeah.
So slightly different topic. Best of luck making this work. I was in a group. We were trying to do an ARM64 laptop for about 3 years, and then after never getting any engagement at all from any of the silicon vendors, we had to abandon. We couldn't find any silicon that was available where we could get samples and documentation to even start on this kind of project. I hope you do better than we did. Sorry, Robin? We basically gave up about a year ago. We were trying on this for about 3 years. And in private discussions with some of the silicon vendors, they all thought what we were doing was really cool, but they couldn't engage commercially because they didn't see any business for it. I hope you guys can do better.
So on the slim and light market, there's basically one chip that only started becoming generally available to a lot of people, and that's the Rockchip 3399, which is in all the nice Chromebooks. But that still has the ARM graphics problem. Yeah. So if you want to go down that route, you definitely have to talk to ARM.
Yeah, so we were definitely looking at the portable workstation thing, you know, a ThinkPad, proper, powerful laptop that people could actually carry, not just something to run a web browser, but something where you would build, you know, you do your kernel builds on it and stuff. So we were looking at the server chips with discrete graphics. And then worry about power afterwards, which seems to be the way lots of people are going. There are some things available, but still very few of the silicon vendors that we were talking to were interested. You know, we were talking, you know, we might sell 1,000, 2,000 systems in the first couple of years if we could get things working, and that just wasn't interesting for them. I don't know what is.
Okay, that was it's quite an interesting perspective. So I appreciate kind of the insight there.
Sure. Happy to talk more afterwards if you like.
Exactly, yeah. Any other questions?
Just a comment.
Oh, yeah.
So, ARM sucks at that kind of engagement. I mean, we know that. But I'm hoping that here at the Connect, at least these guys will have a chance to at least speak to the right people and someone will listen. No guarantees about the GPU side, as we're all painfully aware. But maybe on the processor side, there are, like Peter Greenhalgh and company are here, and they are the processor architects, and they are also drinking the ARM on ARM Kool-Aid these days, so maybe something will happen, right? You did say that there's a, Jeremy, you did say that you had some relationship with ARM already, didn't you? I mean, there was some contact, no?
That's just through the server side.
Right.
So, and that's with Cavium, so it's not really,
okay, so it's
not really with ARM. And Cavium is completely unresponsive to any requests. So.
It's a different company now.
Oh, yeah.
No, it's not.
Yeah.
Even worse.
No, it's not.
Yeah.
Different.
Yeah, so we had significant issues with the Cavium ThunderX, and we were going through the 1804 update cycle just a few months ago. What the response we got back from Cavium was essentially, we only support 1604, which you can't even download the ISO from Ubuntu anymore for ARM 1604. Right? So you've got to find some fucking mirror somewhere. We only support 1604. Fuck off. Essentially was what we got from Cavium. We have a ThunderX 2, by the way, if you're interested, which is exactly what you would expect from the mobile side. Throw your device in the trash. There's a Snapdragon 860 out now. You better fucking update to that, or else you're not going to be able to run Android Pie. Right? That's what it is. And that's completely unacceptable for our kind of market. Now, I have noticed on the Chromebook side, and, you know, funny enough, I was at CES and Razer had a fucking dockable phone that you would put into a laptop chassis. That really pissed me off. But the point is that there are actual desktop designs out there using ARM chips. There are actually people using them. The issue is you can't run a full Linux distribution with the same performance that you would expect from an x86 system. So once that is out of the way, I think it's a huge market. Our average laptop sale is $2,000, and we sell stuff that's $500. So for our average sale price to be $2,000, we sell $15,000 bonobos. Those are laptops that are a little bigger than this one.
It's basically that, but you know,
Yeah.
this only has one graphics card. You know, and sometimes that's just not enough for some of our customers. Go watch Pixar's SIGGRAPH video. But yeah, so once the performance hurdles are out of the way, and once we actually can guarantee good long-term support for the hardware, because you don't want to buy a $2,000 or a $10,000 machine and then be like, 18 months after you bought it, hey, the Thunder X4 is out.
Yeah, from a server vendor.
Yeah, from a server vendor.
There
yeah.
are people who had the dual CPU Thunder X's. They're just going to do a release upgrade, which is standard fucking practice, and their system will not boot. Kernel panic within seconds. So that's absolutely unacceptable. The hardware is already there. The Thunder X has enough performance, and power utilization is on par with a similar Intel processor. Put it on a laptop board and support it for longer, and we can sell it.
Yeah. So getting and one of the big things is you're talking about a couple $1,000 a year market was your projections initially, but I guarantee you the x86 market when x86 was just getting going on the desktop was not as big as it is right now, and being able to develop ARM on ARM is only going to encourage kind of that exponential growth on the desktop. So if you ever want to have ARM competing with Intel toe-to-toe on the desktop, outside of consumer, let me browse Google Docs devices, you need to kind of bootstrap that with the initial possibly low volume machines, so that people develop that for that, and you get kind of an increasingly large waves of hardware over time. Yeah. Yeah, I'm hopeful. It's possibly going to be hard to develop something today, but the pieces may be there, and maybe we can build support for it over time, so that if it's not viable today, maybe it's viable in 6 months or a year or 2 years down the line, to start building the ARM Linux desktop.
Oh, but the Linux desktop is already here on ARM, David. We just need to buy a $30 Raspberry Pi, and you can compile everything you need on it. You can run Gentoo on that motherfucker. You can probably compile Gentoo in a month.
Jeremy, I have tried that and realized how painful that is. You can do it, but no.
Can do everything on anything as long as you have patience.
You can compile Gentoo on paper.
You can use fast model as a desktop.
Yeah.
You just need a lot of patience.
Okay.
And here we can.
Yeah, I think that's about it.